Heat treatment, it's the alchemy that can turn a piece of ordinary steel into a masterpiece of strength and durability, or a brittle, useless disaster. We've all been there, right? Putting our heart and soul into a project only to have it literally fall apart in the final stages. Well, today we're going deep on heat treating. We're exposing the 5 deadly mistakes that can ruin your metal, and more importantly, how you can avoid them. Hey everyone, B-Joy here. Listen, I've seen firsthand how frustrating it is to have a project go sideways because of heat treating problems. I've made my share of mistakes, learned some hard lessons, and I'm here to help you guys save your steel. All right, let's talk about overheating. This is the big one, folks. You get impatient, crank up the heat, thinking hotter is better, right? Wrong. See, steel is like a microscopic world in there. When you heat it up, the grain structure starts to change. Think of it like microscopic crystals. Heat them up too much, and those crystals grow way too big. And big crystals mean weak, brittle steel. It's like trying to build something strong out of a bunch of crackers. It's just not gonna hold up. So how do you avoid this? First off, get yourself a decent pyrometer. This is non-negotiable, people. Trying to judge temperature by eye is like trying to land a plane blindfolded. You need to know exactly how hot your steel is at all times. Second, know your steel. Different types of steel have different critical temperatures. Go above those temperatures and you're entering the danger zone. Now, I know what you're thinking, but Adam, I've seen those bladesmithing shows where they get the steel glowing white hot. Yeah, and those guys are masters with years of experience. They know exactly how far they can push it. You, my friend, are not a master yet. So until you've got hundreds of hours of heat treating under your belt, stick to the temperature charts. And remember, if it's glowing like the sun, you've gone too far. Okay, so you've heated your steel to the perfect temperature, you're feeling good. Now comes the quenching, the moment of truth. This is where we lock in all that hardness we've worked so hard to achieve. But here's the catch. You can't just dunk your steel into any random bucket of liquid you have lying around. The quenching medium you choose is just as important as the temperature. Water is the most common quenching medium, and it's fast, really fast. Like, shockingly fast. That's great for getting super hard steel, but it can also lead to cracking, especially with thicker pieces. Oil, on the other hand, is slower and more forgiving. It'll still get you plenty hard, but with less risk of turning your project into a pile of shrapnel. And then there's air quenching, which is the slowest of all. This is usually used for air hardening steels, which are designed to cool slowly. So how do you know which quenching medium is right for your project? Again, it comes down to knowing your steel. Check the data sheet. It'll tell you the ideal quenching medium, and even give you specific cooling rates. When in doubt, ask the steel's data sheet. It's your best friend in the heat treating game. All right, you've heated your steel, quenched it like a pro, and it's cracked. That sinking feeling, it's all too familiar for anyone who's ever rushed through the process thinking the hard part was over. What went wrong? Well, you might have fallen victim to one of the most common heat treating mistakes, skipping the tempering process, which is absolutely essential for strong, reliable steel. See, when you quench steel, you lock in all that hardness, but you also trap a ton of internal stress inside the metal, making it brittle and prone to failure. It's like a coiled spring ready to snap at the slightest provocation, just waiting for the right moment to break. Tempering relieves that stress, making your steel tougher, more flexible, and far less likely to crack under pressure or impact. Think of it like this. Imagine you're stretching out a rubber band as far as it can go, feeling the tension build. If you keep stretching and stretching, eventually it's going to snap no matter how careful you are. But if you let go a little bit, give it some slack, it'll be much more durable and last a lot longer. That's exactly what tempering does for steel. It eases that internal tension, making the metal resilient. It gives it that little bit of give it needs to withstand impact and stress, so your project doesn't fail when it matters most. So, how do you temper steel? The good news is, it's not as complicated as you might think. It's actually a lot simpler than it sounds, and you don't need fancy equipment to get started. You're basically just heating the steel up to a much lower temperature than you did for hardening, usually between 350 and 600 degrees Fahrenheit, holding it there for a specific amount of time, often an hour or two depending on the steel and the result you want, and then letting it cool slowly in the air, not rushing the process. The exact temperature and time will depend on the type of steel and the desired hardness, so always check your steel's specifications. Now you can get all scientific with tempering ovens and precise temperature control for perfect results. But for most applications, a simple oven or even a toaster oven will do the trick just fine for hobbyists and small projects. You can even use a torch and a keen eye if you're feeling adventurous, watching the colors change as you heat the steel. Just make sure you're using a tempering color chart to get the temperature right, since color is a great indicator of heat. These charts show the different colors that steel turns as it heats up, allowing you to gauge the temperature pretty accurately. Remember, tempering isn't optional. It's the difference between a tool that lasts and one that fails. It's a crucial step in the heat treating process that will make or break your project. Don't skip it. Your steel and your hard work deserve the best possible outcome. We've all been there. You spend hours shaping, grinding, and perfecting your piece only to have it all go sideways in a matter of seconds. You pull your project out of the quench tank, and it looks like it went through a taffy puller. All that hard work, and now your blade or tool is bent, twisted, and nothing like what you intended. Warped, twisted, and utterly useless. It's a frustrating sight, and it can feel like a total loss. The culprit? Uneven heating and cooling. This is the silent saboteur that ruins so many promising projects. See, when one part of your steel heats up or cools down faster than another, it creates internal stress. These stresses build up and force the metal to move in unpredictable ways. And as we learned in the last chapter, stress is the enemy of good heat treating. It's what stands between you and a flawless result. So, how do you avoid this unevenness? How do you keep your hard work from being undone at the last moment? Well, it starts with your furnace. The foundation of good heat treating is a consistent, reliable heat source. Make sure it's evenly heated throughout. An uneven furnace is a recipe for disaster no matter how skilled you are. You don't want any hot spots or cold spots. These temperature differences are what cause the steel to warp and twist. A good way to check this is to use a pyrometer to measure the temperature in different areas of the furnace. Take your time and check thoroughly. Next, think about how you're placing your steel in the furnace. Placement matters more than you might think. If it's just sitting directly on the bottom, it's going to heat up much faster on that side. This can lead to uneven expansion and ultimately warping. Use a heat-resistant rack or even just some pieces of scrap metal to elevate your project and allow for even heat circulation. This small step can make a big difference. And don't forget about the quench. The way you cool your steel is just as important as how you heat it. Just like with heating, you want to make sure your steel is cooling evenly. Uneven cooling can undo all your careful preparation. Agitating the piece in the quenching medium can help with this. Keep the liquid moving around the steel for a more uniform result. You can also use multiple quenching baths to avoid drastically changing the temperature of the medium. This helps prevent thermal shock and further reduces the risk of warping. Remember, even heating and cooling are crucial for preventing warping and ensuring the success of your heat treating. Every step you take to control temperature pays off in the final product. Take your time, be meticulous, and your projects will thank you for it. With patience and attention to detail, you can avoid the heartbreak of warped steel and achieve results you'll be proud of. Okay, we've covered a lot of ground, but there's one more sneaky mistake that can ruin your heat treating: decarburization. It's a problem that often goes unnoticed until it's too late, quietly sabotaging your hard work and leaving you with steel that just doesn't perform the way you expect. This one's a silent killer, slowly weakening your steel from the surface inward. It doesn't make a dramatic entrance, but its effects can be devastating over time. So what is decarburization, and why should you care? Simply put, it's the loss of carbon from the surface of your steel. Carbon is absolutely essential for giving steel its hardness and strength, so losing it means your steel is left vulnerable. And since carbon is what gives steel its strength, losing it is a big no-no. Without enough carbon, your steel can bend, crack, or even break under stress. Definitely not what you want in a finished product. Decarburization happens when steel is heated to high temperatures in the presence of oxygen. This is especially common in open forges or furnaces where the air isn't controlled. The oxygen reacts with the carbon in the steel, forming carbon dioxide, which then floats away. This chemical reaction is invisible, but the damage it causes is very real. This leaves behind a layer on the surface of your steel that's depleted of carbon and much weaker than the core. Over time, this weak layer can lead to premature failure or poor performance. So, how do you prevent this from happening? The good news is there are several effective strategies you can use. The best way is to control the atmosphere inside your furnace. By limiting the amount of oxygen, you can drastically reduce the risk of decarburization. Ideally, you want a neutral atmosphere, meaning it's neither oxidizing nor reducing. This balance helps protect your steel during the critical heating process. You can achieve this by using a specialized furnace with atmosphere control or by packing your steel in charcoal. The charcoal acts as a barrier, shielding the steel from oxygen and preserving its carbon content. Now, even if you take precautions, some decarburization might still occur. It's almost impossible to avoid it completely, especially in less controlled environments. The good news is that it's usually a very thin layer that can be easily removed by grinding or sanding after heat treating. This step is crucial for restoring the steel's full strength at the surface. Just be sure to remove enough material to get past the decarburized layer. Skipping this step can leave your finished piece weaker than you intended. Decarburization might be a silent killer, but it's a beatable one. With the right knowledge and a little extra care, you can keep your steel strong and reliable. By understanding the causes and taking preventative measures, you can ensure that your steel retains its strength and integrity, giving you confidence in every project you complete. Alright, let's recap those 5 deadly heat treating mistakes. Overheating wrong. Quenching medium, skipping tempering, uneven heating and cooling, and ignoring decarburization. Avoid these errors and your steel will be indestructible. Now, a couple of pro tips before we wrap up. First, invest in a good thermometer or pyrometer. I can't stress this enough. Second, practice on scrap metal first. Don't experiment on that awesome knife you're making until you've got the process down pat. And finally, patience beats regret. Don't rush cooling. Smash that like button if you learned something today, and let me know in the comments what your worst heat treatment fail was. We've all been there, so don't be shy. And hey, next week we're getting really experimental. Can you heat treat steel in a pizza oven? Spoiler alert? Yeah, kinda. Make sure you're subscribed so you don't miss it.